Okay. So, hey everyone. Hey, Dawood. Hey, Khan. So, today we are back with another Inspire session, and today, this time, it's topic of machine learning in the browser with TensorFlow using TensorFlow JavaScript. So, without any further ado, I'll just give it to Dawood and do the introduction. Hey, Dawood.
Amazing. Yeah, thank you so much, Sundar, for the quick intro. It's really exciting to see everyone on the screen, including myself. Hi, Salman. We have Rashid, and then also we have Manish over here. But we have our main speaker, who is Okan, a Microsoft MVP, of course. So Manish and Rashid will be making the introduction for that. But let me invite in quick. Hi, Salman. It's been a while.
Hey David, how are you doing, everyone? It's been some time since I've been on, but it's super amazing to have everyone here. And Vishet, amazing member. He's been in the Discord with all of us and in the community. So it's awesome to have him finally in the program. So welcome on board, Vishet, and excited for today's talk as well from again.
Exactly. Congratulations, Rashid, and every LEN ambassador who joined us. We are truly excited to have you, and it was just an honor to pass over to Salman so that Salman does the congrats to you. Because, you and Salman have had a series of interaction, even Dan, myself, and you. So, congrats to you. And just a quick one. How does it feel being an ambassador? What's the positive vibe around so far?
So I can say that for me it's been great. It's just been a day, but it's already wonderful interacting with everyone. There are so many people. There are different leagues where you can know about different tech stuff. So it has been pretty cool. It has been pretty cool for me, and I'm looking forward to more of it.
Amazing. So that is Rashid for you. And Rashid has been doing so much amazing stuff. I think machine learning inclusive, and has spoken in many platforms. So it's finally great to have you and all the Learn ambassadors. Hey Manish, it's been a while. So I'm just going to pass over to Manish. So Manish, you can do the, thank you so much for joining us today. And Manish has also been an MSP for quite a while now. So Manish, I'll pass over to you so you will introduce Okan on our behalf and also say hi to our audience.
Hello everyone. I'm excited for today's session with Hokan. And while speaking about Hokan currently holds a Master of Science degree in Electrical Engineering, and also in addition he holds a Master's degree in Leadership and Organizational Behavior. So he has also taken courses on university level in psychology, interaction design, and human-computer interaction. He also has 20 years of software development experience in various positions such as developer to architect and team lead and many more. Also, he is currently working as a manager for AI and big data at MSInspir. It is a Norwegian consultancy company, and not last, he is a AI MVP. So I'm quite excited for today's session.
Amazing. That was a huge intro. I sense there's some sort of happiness over here on Rashid's face. Rashid, do you feel some connections between you and then Hokan right now? Because we're talking about TensorFlow, right?
Oh, I do. So I've been interested in machine learning all these times, and hearing from Hokan about TensorFlow.js and machine learning on the web, it's going to be exciting.
Awesome. Yeah. So we still have Salman here, and Salman would be having one or two interactions as time goes on, if anything, with Håkan. But yeah, I think we can pass it over to Håkan so that you go ahead and have your session.
Yeah, thank you so much. First of all, I just want to thank everyone here for inviting me in here for this meetup. I feel really honored to be able to speak for you guys. So let me just share my screen first. So so the topic for today's talk is, as we've said, is how we can use machine learning in the browser with TensorFlow. And as David mentioned, this is really a game changer, because now we can actually use machine learning with the tools and the knowledge that we already know as web developers. So we don't really need to learn a new language and a new set of tools, but we can just use the things that we already are experienced in, and we can use them to enhance our current applications. So, but before I start, I can say a couple of things here about myself here. So my background is actually mostly in human-machine interfaces for process automation and robotics. And my educational background, as was mentioned, I have a master's degree in electrical engineering and also a master's degree in behavioral science. And I'm also interested in artificial intelligence and Internet of Things. So I've taken some classes at MIT in that. And I'm also a Microsoft MVP in AI, and I'm quite involved in the local community here in Oslo, Norway. So I'm part of the Oslo AI meetup, and I'm also the chairman for the Norwegian.net user group in Oslo. I think that's enough about me. So this is the agenda here for this presentation. So first of all, before we start talking about TensorFlow, I think it's quite important that we are all sort of on the same page. So I'm going to give a quick introduction into what is machine learning and how does it actually work. And then after that, we're going to talk a little bit about TensorFlow, and we're going to go more into depth about TensorFlow.js. And we're going to have a demo. I will give you a demo about TensorFlow.js, and then we'll also see how we can build a simple image classifier application. So I think we just dive right in. So what is machine learning? A lot of people, they think that machine learning and AI is something new because it's such a hot topic today. But actually, it dates back already back to the end of the 50s. So there was a guy who's called Arthur Samuel. He said that machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. But we can also say that machine learning is sort of a pattern recognition in historical data. So some of the current applications of machine learning is predictions. So one classical example is prediction of house prices. So maybe you already know the prices of existing houses, and you know how big they are and how many rooms they are, and then you can predict what will the price for a new house be. Or you can have recommendation systems. So for example, maybe based on the types of products you have purchased in the past, then a machine learning algorithm can recommend a set of products that you would probably be interested in. We can also use it for clustering. So an example of that is clustering of customers. So you can have a set of customers, and they maybe want to cluster based on a range of perhaps interest or what type of buying power they have, or something like this. And we can also use it for image recognition, text recognition, and speech recognition. So one of the types of machine learning is called supervised learning. And what we do here is that we have access to some historical input and also historical output. And with these two, we can build a model. So with this model, we can bring in new data, new real-time data, and we train the model, and then this trained model can give us a new recommendation. So we're going to have a look at how this is done in a short while here. But as I said here, machine learning is nothing new. It has been around since the 50s. So you might ask yourself, what is the actual reason that it's such a hot topic today? So we have a number of enabling technologies that actually has made machine learning a success now. So one of them is sensor technology, because in order to do machine learning, one of the things that we actually need to have is we need to have lots of data. So we have now access to cheap sensors that can give us access to real-time data. And we have also access to big data solutions, so we can do transformation and load in the cloud, for example. And we also have access to machine learning algorithms that will scale in the cloud and that we can access. And we have APIs and services that we as developers can use, so we don't have to start, from scratch. So these are sort of 4 of the enabling technologies that actually makes machine learning a success right now. So traditionally, we can write machine learning in any language actually, but there are 2 big main languages that are mainly used because there's lots of help libraries that you can use. So one of them is Python and the other one is R. So from a historical perspective, the people that have used Python has mostly come from a computer science background, whereas the people that are using R has more come from a statistical background, and R is probably more used in academia than in the industry. Now that we know a little bit about background of machine learning, then we can go into more about TensorFlow. So TensorFlow is an open source library that was developed by the Google Brain team, and it express algorithms involving something which is called tensor operations. We will have a look at these operations too. So tensors they are sort of n-dimensional matrices that represent our data. And one of the big things with TensorFlow is that it supports distributed computing, so that we can do computation that will scale, which is a good thing here, especially if you want to do, for example, neural networks, or if you want to do deep learning. What is a tensor? So tensor is something that comes from mathematics. So in mathematics we can differentiate between scalar, which is a real-time number, and you can have a vector, which is sort of a collection of a number of numbers, or you can have a matrix, which is like a 2-dimensional vector. And then we can also have a tensor. So a tensor is actually a container that can contain any of these 3 different types of items. So if we use a TensorFlow here in Python, for example, what we can do is we can import TensorFlow as TF, and then we can start up a new session based on TensorFlow.session, and then we can define 2 constants here. So we define the constant called A, which is 10, and the constant called B, which is 32. And then we can do a session.run, and then we can add these 2 numbers and print it out on the console. But then we also have TensorFlow.js. So TensorFlow.js, that's a JavaScript library both for training and deploying models in the browser and on Node.js. So as I mentioned here, the benefit here with TensorFlow.js is that then you don't need to learn Python, or you don't need to learn, Jupyter Notebooks or anything like that. So you can focus on the tools that you already know, with just the regular JavaScript libraries that you have, and then just learn what is specific to TensorFlow. And with that said, we are going to go into a quick demo here of TensorFlow, where we will build an application here from scratch. So let me switch here over to Visual Studio Code. So here in Visual Studio Code, we have an index.html file, and in this file we're just referencing 2 scripts. So one is the TensorFlow.js script, and the other one is something called TensorFlow.js visualization script. And then we also have a script file. So right now the script file is almost empty. The only thing that we do is we print out the console log hello TensorFlow. So let us run this in the browser just to make sure that it actually works. So it's actually in this script file, this is where all the action will take place in a short while here. So let me switch over to the browser. So this is the browser, and then we load this file. Then we can see that we're printing out hello TensorFlow, and then we can load TF, so we can see that the TensorFlow library is actually being loaded. So that's a good thing. Then we know that we have all the necessary libraries loaded in our browser. So then what do we want to do with this thing? Yeah, so the thing that we would like to do is we would like to be able to get some data from an API or from a file and load that data and then do machine learning of the data. So we have some data here. So we have some car data. So in this set of data, which is a JSON file, we have the name of the car, and we can see the miles per gallon, and we can see the horsepower, for example. And what we would like to do is we would like to investigate, is there a relation between the miles per gallon and the horsepower? And then if there is a relation, can we try to predict the miles per gallon based on the horsepower? So the first thing that we need to do is we need to be able to load this data into our JavaScript application. So let us take some code here, like this. And then we go over to Visual Studio Code. And we paste this data. So what we do here, this is a function here where we are retrieving the JSON data using fetch. And then what we do then after that is we want to clean this data, because the only data that we're actually interested in is the miles per gallon and the horsepower. So we map the cars data into some JavaScript object. So we only have MPG, which is miles per gallon, and horsepower. And then we also do some cleaning of the data. So we filter out if there are any null values. We don't want to have the null values. Then we filter out the null values. And then we return the clean data set. And then the second thing that we would like to do is we would like to be able to plot the scatter plot so that we can actually see, is there any correlation between these two data sets? So then we need to use this TensorFlow visualization library. So let us add the function here again. So this function, which is called run, so this is sort of the startup function of our application. So the first thing that we do is we retrieve the data through this function getData, and then after that we map this data to x and y values. So on the x value we will have horsepower, and then on the y value we will have the miles per gallon. And then after that we are using this TensorFlow visualization component in order to render this as a scatter plot. So we can just use TensorFlow visualization render scatter plot, and we can set some properties here, like the name of the plot and what should be the name of the X label and Y label and how big the plot should be. And then we will expand on this function in the short while here. And then we add an event listener, so when the DOM content has been loaded, then it should run this function that we just added here, the function run. So let us save this file like this, and then let's go back to the browser, and let's go back to our file here, and let's reload it. So now with this library, the TensorFlow visualization library, what we will get here is something called a visor. So what a visor is, you can see here on the right-hand side in the browser, that's a tool so that you can visualize your data while you're working with it. And that's very handy to have, so that you can do a plot of the data and see, are there any correlations or are there any missing data and so on. So right now we are only plotting this as a scatter plot here. So here we can see on the x-axis we have the horsepower of these cars, and then on the y-axis we have the miles per gallon. And then you can actually see here that it seems that there is some sort of correlation between the miles per gallon and the horsepower. And that's a good thing, because if this data would have been scattered all over the plot, that would have mean that there is actually no relation between these two data sets, and that would have meant that we wouldn't have been able to build a machine learning model, because there's no relation to learn for the model. So this is a great thing here for us as machine learning engineers here, that now we actually know that there is a relation. So then we can use this relation to build the model, and then we can use this model in order to predict what will the horsepower be, for example, based on the miles per gallon. So so the goal here is then that we want to train a model where the input is one number, which is horsepower, and then the prediction is another number, which is miles per gallon. And that means that we have a one-to-one mapping between the input and the output. And what we'll do is we'll use these values, and then we'll feed them into a neural network. And this neural network will learn from examples so that it can predict miles per gallon from horsepower. And this is an example of what is called supervised learning. So then the first thing that we want to do here is we want to define our model. And so a model seems maybe complicated, but it's basically just what type of algorithm do we want to use so that this model can compute an answer for us, or a recommendation. So in machine learning models, they are algorithms that they take an input and then they produce an output. So in this case, we'll use a neural network. And here the algorithm is a layer of neurons with different weights that will decide what the output should be. And as I said, in order to develop this model, we need to give it some data that it can train upon. And during this training process, the algorithm will learn the best values for these weights that I was talking about. So let us add a new function here to our script. To do the code, and then so here we have a function called create model. So that's a function that we want to use in order to create our machine learning model. So the first thing that we can see is that we're calling TensorFlow. So that means that we don't really need to learn a lot about the intricacies of building a machine learning model. Instead, we can just use the types of models that are already available in the TensorFlow library. And that's a huge game changer, because now you can use something which has been proven and tested out beforehand, and then you can just use it just as a regular JavaScript library. So basically what we do here is we define our model as a sequential model, and the reason for that is because the sequential model means that we have some input that flows straight down to its output. But there are also much more complex models that will enable, you can have, for example, multiple input and multiple output, and you can have branches in your model too. Then after that, we need to add some layers to our model. So we do that with the model add. So in TensorFlow here, the first layer is called a dense layer. So this is a layer that multiplies its inputs with these weights. Actually, it's a matrix, but we call it a weight here in the neural network world. So it multiplies the input with some different weights, and then it adds a number, which is called the bias, to the results. So this is the first layer of the network. So what we need to do is we need to define what is the input shape, which is 1, because we only model function, and then we've added some code here to our run function so that we can create an instance of our model. And then what we do then is we're using this visualization component in order to display some properties of our model. So that's what we're doing here in the last line here, TensorFlow with show and model summary. So let us just save this, and then we can execute this in the browser. And then just a moment here. There seems to be something. One moment. I will do like this.
Yeah, it's actually a game changer because everything in the browser, that's amazing. When you scroll down, I could see that it seems Visual Studio Code was telling you that there was something missing at the down there. Look at this, on line number 59.
Oh yes, yeah. So probably it was just I think it was
Okay. So Fox, go ahead and tell us in the chat how are you enjoying TensorFlow? I think this is amazing. Like, import TensorFlow into your work and then just use it, and it's amazing. Unlike the way one would have had to so far to be able to create machine learning model and all this stuff. This is amazing.
Yeah.
Oh, okay. Sorry, I saw it. It was actually here. This.
Awesome.
Sorry about that, guys. But you see, this
looks
is
like
the way,
Visual Studio Code was giving you the hints about the red thing.
Yes. Yeah, so let us try to run this again here. Yeah. So then we can go over here to our visualization component, and then we can see that it creates a model summary here for our model, and you can see that we have two layers, and we can see that it's got some default names here, and we can see the number of parameters and also some other statistics from the model. So that's a good thing here. Then we know that we've actually created the model, and now the next thing that we would like to do is that we would like to be able to train this model. So the first thing that we need to do is, you remember I was talking about this tensors and what it was, and that tensor is a container for vectors and for scalars and for matrices and so on. But that also means that in order for us to use tensor, we need to be able to convert our data to tensors. So we can't just put in a number into our TensorFlow model, and then because TensorFlow doesn't know how to work with the number or with the vector. So what we need to be able to do is we need to be able to convert our data into tensors. So that's the first thing that we need to be able to do. So let us add a function here that is called convert to tensor data. And let me go back to Visual Studio Codes. Here. So what we are doing here is, the first thing that we do when we want to be able to train our data is we want to be able to shuffle the data around. And the reason why we want to do this is that when we make machine learning when we do training in machine learning, then we do it in batches. So we divide up our training data into small batches. And one of the things which is important here is that the batch should be as representative as possible for the whole data set. So that's why we would like to be able to shuffle these training data around, so that we don't get, if we didn't do this, then we could run into some problems here, that maybe the order of the input data would affect our training algorithm, our machine learning algorithm, or it could be maybe there are some specific subgroups. Maybe in the first half of the training data, maybe for some reason or the other, all that data has just a high amount of horsepower, but that's a relationship that is actually not representative for the whole data set. So that's why we do this shuffle as our first thing. So that's like a good practice when we do machine learning. And then after that, we convert our data to tensors. So that we can see here, we take out the horsepower data into something we call inputs, and then we take out our miles per gallon into something we call labels. So labels is actually the output in this case. And then after that, we convert it into tensor. So we use a predefined function in TensorFlow, which is tensor2d, and then we can just specify what are the dimensions of our tensor. So we define an input tensor, and then we define an output tensor, and in this case, the output tensor is called a label tensor. So now we have our tensors in the right format that we need to have them in order for TensorFlow to use them. And then we come to another best practice, which is called normalization. So what we do here is we find out what is the max in the input and what is the mean in the input, and then we can subtract the mean from the max, and then we can divide with the max minus the min. So that's a normalization. Then we will have all our data in a range between 0 and 1. So we call that a min-max scaling. And the reason why we want to do this is because in many machine learning models, they are designed to work with smaller numbers. So then it takes too much time, or it can be more, maybe there can be some computational difficulties if the numbers are too high. So one nice best practice here is this normalization that we just perform here. So then what we have something we can call normalized inputs and normalized labels, and the labels is the output. And but then it's also one important thing here is that we want to save this input max and input mean and label max and label mean, because if we save these values, then we can do a conversion after our machine learning model is finished with its calculations. Then we want to be able to convert it back to the original scale that we started from. So that's why we're actually saving these things, because then we can easily convert it back. So we will see how that is done in a while. And then finally we return this data and also this bounds, this min and the max. So the next thing that we would like to do is we would like to be able to train our model here. So then we will add a new function here. So in this function, we first need to compile our model before we can train it. And we need to set some parameters for our compilation. So in this example, we need to set what type of optimizer. So this is the algorithm that will decide what kind of updates the model will have as it sees different examples. So as I said here, when we train the model, we will train it in batches. So then it will, after it has run its first batch, it will have learned a little bit about what types of weights it should use, and then it will learn more and more and more after each batch that the model sees during the training. So there are many different types of optimizers in TensorFlow, and here we've picked quite a standard optimizer, which is called the Adam optimizer. It's quite effective in practice, and it requires little configuration. And then the second thing is we need to be able to decide how well our model is performing. So then what we need to decide upon is what is our loss function. So the loss function is calculating the sort of the deviation between the true values and from our model. So here we are gonna be using something called a mean squared error to compare these predictions that are made by the model true values. So then we can get some insight is performing. And then we need also to pick our batch size. So as I said here, what we would like to do is we would like to divide our data set into subsets, and then we will train the model with the first subset, and then we'll train it on second subset, and so on. So here we need to set the size here of the batch. So some common batch sizes range between 32 and 512. So in this example, we've picked the batch size to 32, and actually picking the batch size is almost a science in itself. So we're not gonna talk so much more about the batch size, more than that we've just selected the batch size that we think will be good enough here. And then the second or the last thing here is something called epochs. So epochs, that is the number of times this model will look at the entire data set. So it's important here that in order for our machine learning model to be sort of effective, it needs to look at all our data and multiple times here, so that it can learn as much as possible about the relationships in the data set. So here we have said that we want to have 50 as the number of epochs. So that means that we will take 50 iterations through the whole data set. Yes. And then finally we do a return here. So then we are starting this training loop. So in order to start that, we call a function here model.fit, and then we're using this input and the labels. So again here the labels is actually the output, and then we define the batch size, the number of epochs, and then we can also define some callbacks so that we can, after each epoch, we can visually see it in our visualization component. So I'm going to show you how all of this works in a short while here. But that's also, that's also a benefit here, because now we can use sort of a framework here, so we don't really need to care so much about, how would we, visualize this, how we're going to write code in order to display this after each epoch and so on. But instead we can just use this component and just define a callback, and then it's sort of done. So what we'll do is we'll be able to monitor this model training here, and we will also be able to plot a chart here so that we can see the loss and the mean square error. Yeah. So then it's actually time here to do the training here. So then we need to add some code to our run function. So let us let's find the run function, which is over here. Yeah, so now we're using these functions that we just defined there. So the first function was how can we convert our data to tensors, and then after that we extract the inputs and the labels from this tensor data, and then we are using this train model function that we just described here, and then we are also outputting on the console when the training is done. So let's save this. Let's save this code. And actually, I think I did the same mistake here as before. Let me just check here. One little minute. Yes, I think here should be. Wait. One minute here. Yeah, so like that. Sorry about that, but that's how it goes when you do live coding. So let us go back here to our browser and let's reload this. So now if we have a look here in our visualization component, then we can see here this is for each epoch. It will plot both the loss function and the mean square error function here for us. So again, here we didn't need to do anything to get this the loss function and the mean square error function plotted, which is really, really nice. So we can just use the inbuilt functionality of the TensorFlow.js library. And as we can see here, if we look at the console log, it says done training here. So then the last thing that we would like to do here is then to create. So what we would like to do here is we want to use our model to make some actual predictions. So then we would like to take some data, some input data, which is unknown to the model. And so our input data is the horsepower. So we'll take some numbers that will describe low to high horsepower. And then we can see what miles per gallon will our model predict. And then after that, we can compare that to what we had from before, because we saw that there was this relation that we found out in the start here of our example. So then we will add a new function here called test model. So if I go back to just do the code. Yeah, so in this function here, we will generate some x values here. So we generate 100 new x values that we will feed into our model. And an important thing here is that these values that we have, they need to be in the same shape as the ones that we had for our training. So that then we can use something called reshape in order to get these values into the same shape as we had our input data previous. So just for completion, the shape here is the number of examples, which is 100, and then the number of features per example, which is only one here in this example. So that's our shape of our data. So then we have something called predictions or preds. Then the second thing that we need to do is to be able to unnormalize our data. So this is what I was talking about before here, that we were saving this input mean and input max and so on, so that we can actually convert these values that we get back to our original scale rather than 0 to 1. And then we can return this back. Yeah, that's actually what what I didn't mention here is actually the most important thing here is this. So here we are doing the model predict. So this is where we're predicting what will the miles per gallon be based on the horsepower. And as you see here, we after that we have trained up our model. We don't really need to do anything else. Then we can just call model predict in order to get a new value. Yeah. So that's also very nice here. And then then after that we are using something called data sync in order to get out these values there, because the values there are still stored in a tensor, and in order for us to be able to use these values in regular JavaScript, we use the data sync in order to get it back into just a regular value. And then finally we will use this. We will add this to our run function. So our run function is down here somewhere. Yeah, we're plotting these things out also on the scatter plots. So then we can compare our original scatter plot with these values that we just fed into the model and the values that the model has predicted. And then the last thing we do is we just add this to our run function. So let me just find the run function. The run function is over here. Yeah, so basically what we do here is we do some, we're doing this test model here. So that's about it. So let us run this in the browser here. So now, just because this is an example, we're still doing this model training and so on. But in a more realistic setting, you don't need to do your training after every iteration. But one thing which is important is actually that you should, on a regular interval, you need to check here so that maybe the data has changed, or maybe some internal relations has changed. So it's good to keep an eye on these values, but you don't need to do it every time you run the function here. So here we can see now this is the predicted values here. So now this is almost a straight line here. I think we would have liked it more to be like this, but this has a little bit to do with what type of parameter we set there in our algorithm. So in order to fix this, we will need to try it out again here. And that's also something which is important here with machine learning, because machine learning is a very experimental method. So you would probably never get it right, on your first attempt. So now you need to check. Maybe you should need to add more layers, or maybe there's a third variable that could play a role in the relationship between miles per gallon and horsepower and so on. So so that's something that we need to figure out after a while. But the important thing here is that we can use TensorFlow with quite a little bit of work. So if I go back here to JavaScript, you can see here that with everything. So this is around 200 lines of JavaScript code, and then we've both done the training, and we have used the visualization component in order to monitor the training, and we've also actually visualized the output of a prediction too. And and we didn't really needed to go into any of the intricacies into TensorFlow. We could just use it as any other JavaScript library. So I think that's sort of the big takeaway from this. So now let me go back here to my presentation. addition to use TensorFlow.js to write our own code and to train our own model and so on, we can also import existing models into TensorFlow. So let's say that maybe you have two different departments, and you have one department which is more of a front-end department with JavaScript developers, and you have another department which is more data scientists and machine learning people. So maybe this data science department, maybe they have made a really good model in Python, and then you in the front-end department would like to use this model. So how can you go about to do this? So here is a nice thing that you can do. There's a converter here in Python that you can use. So you can load a model here. So it means that you can convert from a format. So there's something called Keras, which has an H5 format. So you can convert this format to the TensorFlow.js format, which is called a layer format. And you can do this from the command prompt. So you're just using TensorFlow.js converter, and then the input format, which is in this case is the H5 format, and then the path to where you want to have this stored in your local directory. So in Python, we do like this. We import Keras and we import TensorFlow, and then we import a model that we would like to use. So in this case, we would like to be able to use an image classifier library here called the MobileNet. So then we convert our, so that's a Keras model. So then we convert our Keras model to a model that our TensorFlow.js can use. And then when we have done that, then in our JavaScript file, we can just import, first we import TensorFlow, and then we can just import our model by doing what it says there, TensorFlow load layers model, and then we need to point it to where this converted model is. So then what we have done here is that we can just use existing models that are already in use, which has been defined in Python, for example, and then we can use it in our TensorFlow application. So I'm just going to take a little bit of water here. Yeah. So we have touched a little bit upon this, but I think this is quite important to understand that why would we want to use TensorFlow.js. The first thing that we talked about is that now there's no need to learn another language like Python and R, so you can just use regular JavaScript in order to run TensorFlow. And the second thing, which is also important, is that now when we can run TensorFlow on the client, we don't need any round trip between the client and the server, which can be a good thing. And also in terms of security, your user data will be local because everything will happen on the device. So there is no need to worry about someone spoofing or listening in on the conversation. And the third thing here also is that for someone who is not used to machine learning, Jupyter Notebook can seem quite complicated to use. But almost everyone is used to use browser-based applications. So you get the front end, which is really both highly interactive and easy to use. And in addition to that, I said here from the start that one of the bases for machine learning is the access to data. So if we use this on a mobile, then we can have access both to the web camera or to the microphone, or from the gyroscope or from other types of sensors. And we can also take advantage of the GPU. So either what we can do here is we can run existing models. So I will show you what types of existing models exist, and then we can convert them as I showed you before here, so that we can use them. We can convert them to a format so that we can use them inside TensorFlow.js. Or we can also retrain existing models. So that means that maybe you have, a generic model that's maybe is really good at detecting cars, and then you want to specialize this model so that it's specialized just in detecting different types of Tesla cars. So then you don't need to start from scratch. So what you can do is you can take an existing model and then you can retrain it. You can add some layers upon this existing model, so that this new model will be specialized in recognizing Tesla cars, for example. Or you can do what we did here in the first example. You can develop machine learning with JavaScript. So now I'm going to show you a couple of already existing libraries that we can already use today here. So there are libraries for image classification, for object detection. If you want to do body segmentation, or you can do sentence encoding or speech command recognition. So there are many different types of libraries that we can use sort of out of the box. Now we come to our second example here. So now we're going to use this image classifier. You remember I showed you how you can convert an Keras mobile net model. We converted that to this TensorFlow layers model that we can use in TensorFlow. And then I'm going to show you now how we can use this in an application. So let me switch over here to the browser. So the idea here is that we should be able to upload. So the thing here is that now we haven't done anything. We haven't done any training or anything at all. We've just taken an existing model which is called MobileNet, and in Keras, which is a Python library, and then we've converted it to a format that TensorFlow.js can use, and then now we're just going to use this model in our application. So the first thing that we will do is we will select the file here, and then so that this MobileNet is a generic model for recognizing objects. So now we select the model, so we select the MobileNet, and then we do predict here. So now you can see that with this MobileNet, then it predicts that this is a strawberry with 99.9%, for example. So now we're going to have a quick look here at how this is done here. So let me switch over to Visual Studio Code. So this is sort of the page here that you saw. So you have some options and some radio buttons in order to select the right model and so on. So this is maybe not super interesting here, but and also you can see here we are we're loading TensorFlow here from CDN, and I should say that also I didn't mention that in our previous example, because we also loaded TensorFlow.js from a CDN. But you can of course just use npm or Yarn or anything in order to load it. But what is important here is this predict JavaScript file that we have made here. So let's see here. Yeah, so this is in our predicted.js file. This is where all sort of the action is going on here. So when we use our image selector to select an image, we're defining a new file reader, and then when we do unload, we read in the results of our file reader, so we can read in our selected image here. And then we have an event handler here for our model selector. So then we are calling a function called load model with the model that we've selected. So I wasn't so clear about it, but there are two different models that we can choose from here. So in our load model function, we are loading the model with a specific name. And then here, what we can do is we can just use TensorFlow load layers model. And then we have, for example, now the name is MobileNet, for example. And then we have this model stored here in our application. So here we have a library called TensorFlow.js models. And then we have the name was MobileNet, so it will go to this directory. And then over here we have model.json. So that's actually all we needed to do in order to load our model. And then how do we do then when we want to use our model? So then when we click here on the predict button, it gets the image, it gets the model name, and then similar to what we did in our previous example, we need to do some pre-processing here of our image in order to get it into the right, size and shape, so that TensorFlow can actually use it. So we do the pre-processing of the image and makes sure that it is in a TensorFlow form, that is in a tensor format. And then after that, all that we need to do is to call model.predict with our tensor. And then this is sort of some method chaining here, so we can call data here in order to get the predictions. And then after that, we just select the top 5 predictions. But the important thing here was that we didn't really need to do anything here in terms of machine learning. So we could use an existing model. So the only thing that we need to do is we needed to load our model, and then after that we needed to make sure here that our input data is a tensor and that our input data is in the right size and right shape. And then after that we could just call model predict in order to get the classification of the image. And then just for clarity here, so what we'll have is we will get for each classification, we will get the probability, and we'll also get the class name here. So the class name is actually just an integer. But then what we've done here is we've taken out all these class names that exist and we've put them into file here called ImageNet classes. So then we can just do a simple mapping here between the class name as an integer and the class name as a text. So So if we look at all of this, this is some 75 lines of code in order to do an image classifier. So so that shows a little bit here of the sort of the flexibility that we can both develop our machine learning algorithms ourselves, as we did in the first example, and we can train and we can select our ML model ourselves and so on, or we can do as we did here in the second example. We can use an already existing model, and in this case we used the Keras model, and then we just converted it to a format that TensorFlow can use, and then we can use this model in our own application without that much work. So let me get back here to my presentation. Now I would like to, in the last part here of my presentation, I would like to talk a little bit about some real-world examples where TensorFlow.js has been used. So one example is in Uber. They have a visual debugging tool for their applications that is called Uber Manifold, and this debugging tool is using TensorFlow.js. So they're using machine learning in order to do visual debugging of their code. Another example is from Airbnb. So when you want to rent something from Airbnb, you need to be able to verify your ID. So then they have something called identity document detect. So that's a function that will alert if there is some sensitive information in this picture that you will upload. And this has also been done using TensorFlow.js. Then my last example here is from the world of music. So then there is something called Magenta. So Magenta is actually a set of machine learning models for music generation. So this is actually quite cool. So if you have time, you can look further into this. And then lastly, I have also some references here. So you can see more examples and more tutorials on the TensorFlow.org homepage. I can also recommend a Coursera class, which is called Introduction to TensorFlow. Or if you want to know more about this image classification example, you can see there's a video series by Deep Lizard where you can learn more about that. So yeah, so if you want to reach me, you can either add me on Twitter, there I'm called Agrevlis, or you can just send me an email. So with that, I would like to thank all of you who are watching this now or later, and thank you so much for inviting me.
Yeah, we are super excited to have you here. It's been amazing and it's been a great episode. Lots of learning with machine learning in the browser with TensorFlow. I always heard about it, but I never knew what exactly TensorFlow, is, and it's really great to have exposure today. Salman and Rashid, anything from your end?
Oh,
No,
I
I
feel,
thought it was amazing too.
I feel
Amazing.
it was really great what the speaker just talked about, and how he showed us how we can use the layers API to train a model right in the browser, use WebGL, use GPU. So I think it's really cool what we can do with this. Um, and he also showed how to use a saved model, which is again anything you make in Keras or TensorFlow or any other framework, just put it into a TensorFlow.js format. So I think that's super cool, and I can't wait to do more with it.
Exactly. Awesome. Hey Manish, any last words from you as well?
Yeah, actually, it was really amazing. Like I am currently new into machine learning, but yeah, it was great to hear from Hokan. And yeah, I will be soon bringing Rishit to know more about machine learning, as I have seen his post recently. Yeah, I will. I loved it. Yeah, thanks, Daud,
Awesome.
again for arranging this.
It's amazing. We just want to give a huge thanks once again to Håkan for making this episode a success. We will make sure to have you back on MSInspir, and then we'll keep working together as AI MVPs. It's really amazing. A lot to learn from you.
Yeah.
So yeah, viewers, thank you so much. Salman is a lover of AI, has implemented, bots and all this stuff. So I'm really excited that Salman also joined us today. So we would end it here and then say a very big thank you to everyone who joined us. And that this episode, once has been recorded, would always be on YouTube. And we'll keep promoting it from our end in our emails. If you received an email about this session today, you should just know that you can always go back to your email and check it out. So thank you so much.
Yep, thank you so much.
Thanks everyone for joining. So stay tuned, and we'll be back by Wednesday again with an Dev to Be episode in which we'll have Scott Henselman with us. So stay tuned for that also. So thanks everyone joining. Thanks Dao. Thanks everyone. So we'll meet you back soon. Bye bye.
Bye.